Good to go, Ken.
All right, great. Thanks, everyone. It's 10 o'clock now, so we're going to get rolling here. I appreciate everyone that's logged in. This will be recorded. So we're excited today to have Bill Gennari from Interval Data Systems with us. He is the CEO and co-founder of Interval Data Systems. Greg Kamar with us, who is their CTO and also a co-founder, and Kevin Fuller, who is their executive VP. And they're going to be presenting to us facilities operations in a world of COVID, talking about HVAC, trying to help us better understand what DESE is looking for, what the state is looking for, but more importantly, how can we accomplish what we're being asked of? So there's going to be a lot of content today, and what we're going to ask is to make sure people mute their mics during this presentation and use the chat box to ask questions. We'll be monitoring the chat box. If it's a question that makes sense to interject the presentation and ask at that time, we'll do that. Otherwise, we'll just mention in the chat box. That'll be covered later in the presentation. We do want this to be open for Q&A because there's a lot of questions out there, and there's a lot of misunderstandings of what people are looking for from both sides, from the Mass Teachers Association, from the superintendents,
Okay,
from our
Bob.
end. So just make sure that we're ready. And
Oh, they came in? Oh, good.
can someone mute their microphone? Mike, well, you're gonna have to manage that today, buddy, to make sure people are muted. If you see their button on, please just click it and mute them. So without further ado, we're gonna jump into our presentation here, and I'm gonna turn it over to Bill to do an intro for his team. So take it away, Bill.
Okay, that's good. Better than none.
Denise Baroni, please mute your microphone. Thank you. You're ready, Bill. Go right ahead.
Sorry, I was on mute. Can you hear me now?
I can hear you now. It's perfect.
So, I was doing what I was told. Okay,
Yeah.
So we're going to give primarily a HVAC perspective on how to operate your facilities in the world of COVID. I'm going to do one or two slides and turn it over to Kevin Fuller, our Executive Vice President, to do the rest of the presentation. Let's go to the first slide. So just a really short background on us, then a section on HVAC considerations when you're reopening schools, and we're going to be primarily focused on the requirements communicated by the Commonwealth as well as DESE. And then we have another section of some case studies of verifying ventilation in one case a school, another case an office building. All right. So a little bit of background on us. We are what's known as automation consultants. We focus solely on helping make sure the automation in the building works per design intent. We've been doing it for a long time. We've dealt with all of the major control systems. As a company, we have background in controls, design, and a lot of experience in sequences of operation and helping engineers adapt their sequences to the latest ASHRAE standards. We have background in controls programming, and a very important part of getting a building to operate the way you want. We have experience in enterprise software development. Over the years, we've evaluated hundreds of buildings, which has really given us the background and knowledge as to how to help buildings, how to help you operate buildings efficiently. And within the school system within the state of Massachusetts, we're working with Belmont and Arlington on their new high school projects. The best time, of course, to help get the automation right is early in the design phase. So as a company and people, we just focus on one thing, helping make sure that the building operates consistent with design intent for the life of the building. Just a little bit of background on us. Now, also presenting today will be Kevin Fuller. He's our Executive Vice President of IDS, along with Greg Smar. Greg is the other co-founder of IDS. So without further ado, I'm going to turn it over to Kevin, and then take it away, Kevin.
Thank you, Bill. Before we dive into the main part of the presentation, I just want to sort of acknowledge that we realize, facility departments, you've had a lot of things put on your plate related to COVID-19. Lots of things that you didn't have to worry about a year ago are now, tasks that you do have to worry about. HVAC is just one of them. While a lot of what we talk about is a little bit centered on schools, given that they're going through a reopening process now, I also realize you've got existing facilities. So whether it's police and fire stations or senior centers, town offices, et cetera, you're dealing with a lot. But today we are going to primarily talk about HVAC, mostly look at ventilation, a little bit on filtration, and touch on air cleaning, sort of where that kind of fits into the mix. So the first section today is looking at reopening schools. So what we're going to do is look at some recommendations from both the Commonwealth and from DESE, Department of Elementary and Secondary Education. From DESE, there's a ventilation and HVAC system recommendations. So the first thing is kind of an overall approach that that's in their statement guide that was published late in July. And it's important that they recognize that not all schools, not all buildings are operating, with the same equipment, with the same, under the same set of circumstances. So, it's important to look at those differences. We wholeheartedly, agree and support that. The goal really here is to do the best job you can with the systems that you've got. There's no, magic wand that, somebody's not going to come in and magically upgrade all your systems. So you've got to sort of deal with the buildings that are in your portfolio and do the best job that you can. And that's, that is what this is all about. So going back to DESE and the ventilation side of it, it's a, they make a fairly general statement about, adjusting air, adjusting increase the flow of outside air. Now, other places, ASHRAE, their recommendation is to use 100% outside air, so that you're, constantly refreshing the air in the building. That's a nice theory. In reality, that doesn't work. Systems have limited capacity. You simply can't bring in 100% of 10-degree air or humid 85-degree air and expect your buildings to maintain, safe and comfortable. Certainly increasing the amount of outside air and amount of ventilation, is the topic that we'll revisit here frequently. Now, if you don't have a BAS in your buildings, older buildings, then again, DESE's recommendation to look at opening windows and doors, if that can be done, safely, what the options to do that. And, also looking at air intake with box fans in the windows. And certainly, if you're in that situation, that type of building, you want to naturally ventilate as much as you can. But you do have to maintain comfort, especially in a school building. It's been proven many times over that the facilities, the condition of the facilities and the comfort there has an impact on education and people's ability to learn effectively. While you want to ventilate as much as you can, naturally in those situations, you still got to maintain comfort. And, frankly, nobody's going to be happy about having a box fan blowing on them when it's 10 degrees outside. So it definitely gets harder to do that in the winter in this climate. And then finally, DESE recirculating, evaluate how to eliminate or minimize the amount of recirculation. And, this is really kind of the key to it all. Frankly, the outside air, 100% outside air, the point of that is not, is to reduce the amount of air that's being recirculated. So if you do get some virus particles into the airstream, you don't want them being recirculated constantly. This is also where filtering and air cleaning, comes in to help minimize the air that does need to be recirculated because of the capacity of the system. And we'll touch on those things a little bit more as we go through. A couple more things from from the DESE's guide. Ventilation, running buildings longer, an extra couple hours before and after the building. And, you know, certainly if there are people in the building in those hours, you know, then, you know, you want to make sure that this being, you know, maintained, you know, ventilated well and safe for them. But a lot of the purpose of that is to really provide an air flush, so that you're completely turning over, completely refreshing the air, you know, after the end of the day when it's been occupied, and then make sure it's, you know, nice and fresh in the morning when people are starting to come in. You know, and one thing that there was a company up in Minneapolis that did some research on what's the most efficient way to do an air flush. And what they found is that it's actually the most efficient from an energy perspective and hence a cost perspective to try and flush that air as quickly as possible. Now in cold climate and cold weather, that means that the space temperatures are going to get lower than, you know, you necessarily would normally have them go, perhaps. But when you do a really fast air flush, you know, you don't have the issues that come along with the building mass getting cold or the furniture getting cold. You know, it's a very temporary thing with the air, so the building will actually recover really quite quickly, you know, after you've done that flush. So even if you've, you know, drop space temperatures down to, you know, low 60 degrees or something of that sort, it'll bounce right back, and then the, you know, furniture won't really have changed its temperature all that much, so people will be comfortable to come in and sit down. If you've got windowless spaces, you know, that's, especially if you're dealing with natural ventilation buildings, you know, that's something to be very careful about, making sure that there is adequate HVAC. You know, I mean, if you've got a mechanical system, I mean, it should be designed to properly supply fresh air and exhaust the existing air in there. So that shouldn't be a, you know, big problem for, you know, properly designed mechanical systems. But, you know, that is an area of consideration for buildings relying on natural ventilation. And then bathrooms, the DESE recommendation is, you know, open windows there if you can, if it's, you know, there's no safety or privacy issues, and it doesn't interfere with your HVAC operation. And so the things you want to make sure is, you know, you want to make sure that opening bathroom windows doesn't cause that air to flow into other parts of the school in any way, because that's, you know, definitely going to be a bad thing. If you do have a BAS system in there, running the exhaust fans continuously, as opposed to perhaps, you know, occupancy sensor based, is a good thing to make sure bathrooms are exhausted well. And like anything, if you're running an exhaust continuously, you want to make sure that there's makeup air, so that you don't make other parts of the building negative. The bathrooms themselves want to be a little bit negative, but the rest of the space around it doesn't want to get to be negative pressurized. Okay, a couple more things that came out of the Commonwealth's Re-Occupancy Guide, which was published back in June. And these guides, by the way, are both available. Links to them all are on the Mass Facilities website. But so the first thing they hit on, a little more detail, outside air and economizers. You know, recommend that you use economizers to full maximum capability. You know, and that's, you know, absolutely you know, the thing you want to do. You know, excellent idea. The economizers, you know, are both when the temperatures are cooperating, and you can do that. You know, it is both the most efficient way to run your building in terms of not requiring mechanical heating and cooling, you know, and it's maximizing your ventilation. So, you know, the economizers, normally anything above 70 degrees in the Massachusetts climate, your economizer goes down to minimum air. And, you know, when you get very cold air outside, you know, you're limiting your air and getting down to minimum air is there. So, you know, when you've got those moderate temperatures, as we do this time of year, I want to make sure those economizers are operating properly, that you're maximizing the outside air. And then in even the more extreme temperatures, you certainly may want to look at increasing the amount of minimum air that comes through. How much air you can bring in is going to depend on the building or depend on the individual unit. So that's got to get looked at with your controls contractor or engineer. But take advantage of that as much as possible. The Commonwealth has a couple of points related to pressurization, making sure that the building is positively pressurized. Frankly, that's the way buildings should always run. That's not particularly different for COVID-19 environment. It is important though. Buildings, always should be positively pressurized so you're not bringing in unfiltered air. Okay, shifting gears a little bit and looking at filtration and going back to the DESE operations guidance. Generally, if you've got filters that are upgradable, DESE recommends that you look at increasing your efficiency ratings of the filters that you're using. So to be a little more specific about that, ASHRAE and the CDC recommend MERV 13 or higher filters. Now that said, going back to not all buildings are created equal, your equipment may or may not be able to handle MERV 13 or more. Not everything will be able to take those. There may be size considerations, although MERV 13 filters are available in a pretty wide variety of sizes. But one thing you certainly need to notice is that it's going to impact airflow. The pressure drop across a MERV 13 filter is going to be greater than it was across a MERV 8 or something lower. And so you're going to have to make sure that you're maintaining the right static pressure throughout your system so the fresh air that you're bringing in is getting to all the places that need it. And then going back to DESE, looking at buildings that don't have upgradable filters, again, revert back then to improving the ventilation through opening windows, etc. Excuse me. And this is where you might want to look at, adding some sort of external filtering options. So portable air cleaners, put a HEPA level filter typically into the building.
We're off, but
and
heading into Boston pretty soon. So
Bill Kavanaugh, can we get you to?
Bill Claybaugh, please mute your microphone, Bill. Thank you.
Is it possible Peter Kelly's on vacation?
Or Mike, can you look, Bill, please?
Bill, I'd love to hear that Peter Kelly's on vacation, but we kind of need you to mute your microphone. Kevin, question while I have you here. MERV 13, I think most people know, but I just want to make sure everyone's aware of the whole concept of how MERV 13 filters sometimes get their rating. And I didn't know if you were going to talk about the whole electrostatic component of a MERV 13 and the shelf life of that filter and how it degrades in a pretty short period of time.
Yeah, no, I didn't have that
okay.
details covered, but essentially, you just kind of gave the answer. MERV 13s, they're, the filtering is, finer, so that does mean that they kind of get clogged up, sooner. So there's an important component to all this, which is keeping up with the recommended, swapping out and replacing of these filters. And it becomes, more important, with these higher level filters to make sure you're getting the filtration that you want.
Right, and just so people are aware, with the MERV 13 media itself, it receives that higher rating because they create an electrostatic charge on the filter media. The problem with that charge is it dissipates over time, especially under humid conditions. So if you pre-order your MERV 13s in June and stockpile a whole bunch of them in a sea container somewhere, by the time you go to install them in December, they've discharged that electrostatic charge in them, and you essentially have a MERV 8 filter. So there is a time component with ordering these filters, and there's also a time component on when you have to replace them. If it's not a true MERV 13, that's something that you should be considering when you're installing these, not to give a false sense of security for people.
Thanks, Ken. All right, so the last part on here, again, the non-upgradable filters where you don't have that option. Some portable air cleaners, can bring, as I said, HEPA level filtering into the space, and typically have the advantage of being able to be portable and moved around a little bit. There are much more expensive options of installing, UV-based or ionization-based systems in your ductwork. Those are pretty big capital projects. you know, not everybody's going to, you know, have the funds or ability to do that. But, you know, those are certainly options for, you know, cleaning air and killing virus, you know, in that approach to go through there. A couple more things on filters from the Commonwealth's Re-Occupancy Guide. And this is really geared, you know, frankly, more towards the facilities staff themselves. When replacing, you know, use proper PPE, gloves, face protection, masks and shields. You know, I mean, this is about, you know, the health and safety of your staff, you know, you folks and your staff, to make sure that you're, you know, not coming in contact with whatever the filters picked up. And similarly, disposing them, you know, you don't just want to take these filters and toss them in the dumpster. You want to bag them and seal them so that nobody else potentially comes into contact with an infected filter. And then, you know, making one of Ken's statements about timing here, you know, just a little bit more of a challenge. While you can't order them years in advance, certainly you do need an adequate stock. And we're hearing about people that are customers that are, you know, being told it's going to take 60 to 120 days to get a filter order fulfilled. So you certainly need to be managing that process, you know, that far out, or stay in, you know, good communication with your supplier to know what the lead times are, so that you don't wind up, you know, getting yourself shorthanded. But, you know, again, to Ken's point, you don't want to have them, you know, so far in advance that they started to lose effectiveness before you install them. So Ken, do we have any other questions we want to address?
I think right now we're good. There was one question about box fans in windows, but I think you're going to cover that later. There was a concern that isn't that just going to spread around the COVID virus? But I think that's in one of your later slides. So if we don't get to it, we'll just get to it at the end.
Right.
But I think you're good for now.
All right, so now let's look at the ventilation issue in a little more detail. You know, we know that good ventilation is going to help mitigate transmission risk. So let's, you know, first look at what that's all about. So as facility operations folks, you know, somebody's going to be asking you what's being done about ventilation. You know, the issues showing up in the news, you know, somewhat frequently these days, and you know, especially with going back to school and the school buildings. You know, concerned parents, students, teachers, you know, administrators, you know, these questions are going to come up. So, you know, what we're going to look at here for the bulk of the rest of the presentation is, you know, ways that you can prove that you've got your ventilation performance, you know, operating as you want, that you've got the data to support and show how well your spaces are being ventilated. You know, that you've got an analytic and a way to actually communicate that information to other people. And this can be done, you know, pretty inexpensively, whether your building's got a BAS or not. So looking at how that method works, you know, when you are dealing with air handlers, you know, return air systems, your BAS is already going to have the points available that you want, which, you know, keeps it inexpensive. You don't have to get any new equipment in that case. And, you know, it requires a relatively small set of points to be looked at and evaluated to see, you know, how much fresh air you're bringing into your space. And we'll go over this points list and talk about this a little bit more. But by doing this, you know, we can build an analytic that gives you a pretty good approximation of how much, what the percentage of outside air is that you're bringing into your building. And then, you know, that gives you a record of you know, how well you've been ventilated, and that, you know, shows that you're looking at the ventilation and how that control is happening. So it gives you the backup to address those questions that are invariably either already come up or soon to be coming up. So here's a simple return air system, air handler diagram. You've got your outside air coming in here on the left. So there's a damper for your outside air and you're measuring the temperature. You've got your return air coming in across the top and down from the top into your mixing box. You know, some of it gets exhausted, but You've got a mixed air temperature here. And then, as we go through this, it's certainly important to know when the fan is on. So, when you're actually supplying this air into the building. So here's the analytic that we'll kind of look at. And just to introduce this to you, what you're seeing here is the black line is showing your outside air temperature over a week's worth of time. We're going to be looking at 1 week charts as we go through this. The blue line is the return air temperature. Orange is the mixed air temp. The blue area at the bottom is the damper position, outside air damper position. The line across the bottom is just showing where your fan's on or off. And then lastly, the calculation that gets done based on this data in pink in the middle is your outside air percentage. So if we take this same graph and put it into context, this is a 41,000 square foot building, school building facility. And, what we can see from this is, for 4 days anyway, the ventilation was really quite good. I mean, the ventilation, so the scale is going from 100 to 200% showing on the scale, but you're representing 100% ventilation. So we're running, anywhere from 80 to 100%, fresh air ventilation, much of those first 4 days. You can see that it's running a 6-day-a-week schedule. So it does run, albeit a shorter day on Saturday, it does run on Saturday. But one of the things that you also see is that on the morning on both Wednesday and Thursday, and then all day Friday, it's running at minimum air. And this shows a couple of things. One, it shows that the minimum is really low. There's 5% or less fresh air coming in when this system is set to minimum air. And clearly it was set up to be as economical as possible and to reduce the outside air as much as possible when it was at minimum. But this may or may not even be meeting ASHRAE 62.1 ventilation levels, even without a pandemic going on. And what's causing that in this case is if we look at the outside air, anywhere that the outside air temperature gets below 45 degrees, the system is shutting down to minimum outside air. So the economizer in this case has a low limit on outside air. And when it gets below 45, it brings it down to minimum. So here on Thursday, it got to almost noon, before it finally warmed up to 45 that day. And then, the economizer kicks in, it opens up, it ventilates really nicely for the rest of the day, but that early morning, there were quite a few hours where you're at minimum ventilation. And then Friday, it cold snap came through, temperature just decreased all day. You never got that air. So this also shows you that, you've really got to look at this over time. Somebody came in on Monday or Tuesday and looked at how well this building was ventilating, they would have gotten a really nice picture. But, Friday that same week, they come in and look at the ventilation levels, and it's really quite low. And last note here is, this economizer operation that's forcing this to happen, that's unlikely to be a simple set point change. You may be able to affect it a little bit with a simple set point change, but more likely the economizer operation is built into the programming and the amount of things that it interacts with. You're likely to need your controls contractor to help adjust this kind of behavior. So this is how this building was operating in winter time or early spring, early March, just before lockdown. If we come and we look at how it works over the summertime, first thing that we see is, it's not ventilating nearly as much, hardly ever. A little bit when the outside temperature gets a little bit lower. We also see that it's running, almost 24/7. So even though the unit's running, and ASHRAE has at times suggested running the systems 24 hours a day, but even though the system is running and the fan's on, if it's not bringing in outside air, it's really not doing the job that running it constantly was intended to do. So you're not getting that ventilation, that you're running the fan for. And, you know, ASHRAE 90.1, the economizer dry bulb limit, you know, again, for this building, it's set at 65. So we do see when the temperature dropped down below 65, you know, again, we got all this nice ventilation, but that only happened for a few hours for the whole week. So everything, you know, most of the time during the summer, the temperatures are sitting above 65. So you're sitting at minimum air, you know, and that's one of the things that you certainly want to be looking at is, you know, where those minimums are, how much air you are bringing in. All right, we're going to look at one other building here and look at it in the 2 seasons as well. So this is a much bigger office building, over 300,000 square feet. And, you know, first thing we can see is that it's actually ventilating, you know, pretty nicely. It's 50% almost all the time. It's running a 7-day-a-week schedule. You know, we assume that's appropriate for the building, building occupancy.
Hello. Hi.
The fan, as you can see, is running on a 7-day-a-week schedule, and those days are pretty long. There are 16-hour days.
Right.
But the thing that you see that's different about this building versus the other is, you know, even when the temperatures in January are fairly low, you know, getting down here near 30 degrees, you're still ventilating. So rather than having that 45-degree lockout point where you go to minimum air, this building's set up much better from a ventilation perspective. And frankly, even an efficiency perspective, is that it's modulating the outside air dampers so that you're still bringing in, you know, you're mixing it in different proportions, but you're still bringing in outside air and, you know, managing that so you can deliver the right amount of supply air or the right temperature and humidity of supply air, but still keep outside air into the mix as low as you need to go. I mean, eventually you get down to the point where, you know, you've got to lock out outside air and bring it down to minimum so you don't trip freeze stats and things like that. But, you know, you can get down much lower than 45 and still have, you know, still be introducing more than minimum air. Looking at the same building in the summer, you know, relatively little ventilation all week, and it's much less consistent. You know, we see it, you know, very much, you know, on and off in terms of what's going on. You know, we can see that the days have been, schedule's been changed, so it's, you know, more 11 or 12-hour days now. Sunday it did run, you know, all day through weekend through Monday because of the space temperature was, you know, driving it and needing some amount of ventilation. But the really interesting thing here is that when it's unoccupied, you know, the minimum ventilation, the damper is set at 30%. When it goes into occupied mode, the fan comes on and we go into occupied mode, the outside air damper is actually being driven more closed. Excuse me. And that's happening because there's demand control ventilation logic into this building. And since it's relatively lightly occupied, you know, the CO2 levels are, you know, never getting anywhere near requiring more air. And, you know, demand control ventilation is an efficiency measure, is trying to, you know, reduce the air to as low as possible and still provide ventilation. But that's kind of, you know, not the goal now. When, you know, health and safety considerations, you know, override, you know, the best in efficiency, you know, you need to sort of look at that. And that's why ASHRAE and others are recommending disabling demand control ventilation. And again, demand control ventilation logic is often very intertwined with other things. It's not simply a matter of changing your CO2 set point. You know, it can be more involved than that. So you may want your controls contractor to be involved in addressing that situation. But, you know, we can see every one of the days here, you know, when it goes into occupied mode, it actually drives the ventilation down because of that DCV.
So Kevin, just while you're on this slide, and some of these newer, you know, tightly built buildings have some issues regarding humidity and relative humidity. And I didn't know if you were going to speak to the point of maintaining a stable relative humidity as part of the control hierarchy in these buildings, so that way you don't start delaminating finishes, you don't have mold buildup, moisture buildup, because we're building essentially submarines these days, you know, and we're relying on our mechanical systems to maintain a stable indoor environment. So how does that relate to all of this? And what do people have to consider when they're making these adjustments to meet these new pandemic guidelines?
So the pandemic guidelines, really aren't, from a humidity perspective, really aren't all that different. I mean, the recommendations are to keep relative humidity in the 40 to 60% range, which is your typical comfortable range. Buildings are by and large built for dealing with dehumidification issues, and to your point, I mean, getting humidity and getting moisture into a building is problematic from all sorts of other health issues, mold growth and finish deterioration and etc. So buildings are set up to do that. I mean, that is why there are limits as to, if it's 85 and humid, you can't bring 100% outside air in because your mechanical system isn't able to, properly cool and dehumidify that air. It's just not sized to bring in 100% outside air, on those conditions. So there are, limits that are going to vary building to building. When was your building built? How was the equipment sized? The more the engineer right-sized the equipment for normal operations, the less room that you have to increase ventilation. So, managing high humidity is still the same issue that it's always been. You've got to keep the air, appropriately dried out and get your supply air down to, 55 degrees to dehumidify when you've got those kinds of conditions. At the low end, there's probably, one building in Massachusetts that's actually got humidification in it. It's just not a thing that's normally done anywhere, frankly. Maybe in desert climates in Arizona, you get more humidification systems, but by and large, you're not going to have humidification systems. So bringing the humidity up to 40% in the winter is just simply not something that buildings are equipped to do. And, adding that in, frankly, is typically, most engineers and folks are agreeing that's not really worth the expense. And it's, adding humidification, the moisture and mold growth problems in humidification systems, are their own sort of challenge to manage. And the impact of COVID, in particular, with humidification, I mean, it's frankly, it's not that affected by humidity until you get to the very, very extremes. They're way outside of comfort levels. So, that's sort of a long answer. Apologize for that, but essentially, you need to manage humidity the way you always have, and the COVID situation doesn't really change that all that materially.
Great, thank you.
All right. So, were there any other questions? I mean, that's as we look through those, those different examples.
So I don't have a question, but we do have Matt Denninger on the call from DESE. Matt's the lucky person at DESE's headquarters that was given the gift of being responsible for HVAC Q&A for the state. So Matt did have some things that he could help explain or cover over. So Matt, I don't know if you can unmute yourself if you want to jump in for a little bit and just kind of give a perspective from DESE's standpoint.
Yeah, sure thing, Ken. Yeah, lucky indeed. Thanks everybody. This has been great thus far, and I think Kevin and the rest of you have really captured the spirit of DESE's recommendations in our HVAC and facilities guidance. So really appreciate that. I think just two things that I would say and want to underscore. The first thing is that we built this facilities guidance with the help of some of the top epidemiologists in the state, pediatricians, and it was really built from a public health perspective, And so, you know, I think that's why the spirit of it is, you know, do the best that you have with the facilities and the systems that you have. But I think, you know, taking a big step back, it's important to remember that, you know, there are certain, while, you know, everyone is taking the facilities and ventilation thing important because it is an important piece of sort of the whole safety pie, if you will. Some of the other things that you hear, you know, in the news and all around are just more important, like the, you know, community spread. You know, you've seen the maps of all the districts and who's in red and who's in green. You know, I think the thinking behind that is like, you know, if you've got a building with excellent ventilation, but you're in a community with a high community spread, you know, you don't want to be going into the building, right? You don't want to be, that's you know, you should be looking at the community spread, you know, as sort of your first thing that you look at in terms of safety, and then, you know, down the list to these other things, you know, wearing PP, you know, wearing masks, social distancing, all those guidelines that you've been hearing about for so long. Those are definitely the things that you want to be thinking about. And, you know, so these are the things that we're hoping that districts are weighing. Ventilation is obviously, as I said, really important, and it's part of the piece of the pie, but it's not the whole pie. The other thing that I would say is that I want to underscore, I think, Kevin, you mentioned this, is communication. You know, communicate with your families. I think the ventilation thing is becoming a big deal in a lot of places, and people, parents, teachers are rightly concerned about it. And I think, you know, the best medicine for that is clear communication. Frankly, when people come up to the state and they're asking us questions, it's sometimes because, you know, they're like, I've asked my district what they're doing and I'm not getting anything. You know, what should we do? So, you know, having a good communication plan with like, hey, here's what we're doing with our buildings. We're doing the best we can. Here's some of the improvements that we're making, both in the short term and, you know, thinking in that medium long-term range, because we all know that, you know, once this crisis is behind us, there's going to be, you know, the next bad flu season. There's going to be, you know, another kind of, you know, SARS thing like that. There can be, this can be a conversation, I think, that is perhaps spurred by, you know, the moment, but can really help districts and building facilities managers think about safety in the future. So those are just a few things that I wanted to add to this. It's been a really good and informative webinar thus far, and I really appreciate all the work you guys put into it and all the facilities folks on the line that have been working on their buildings.
Thanks, Matt. I appreciate it. I know you had to run, so I wanted to make sure you were able to get in there before you have to jump on your next Zoom call with a complaining, upset, anxious parent who wants to know about HVAC and MERV 13.
They want the MERV 13s.
They all want the. They don't know what the hell it is, but they want them. They want lots
everywhere.
of them.
They want them taped. They want them taped to box fans and blown around the room.
Absolutely. Well, thank you and good luck with everything. And we're glad that you're able to join us today. So Kevin, Bill, Greg, I'm going to turn it back over to you guys. So if you want to kind of continue, and we can handle some Q&A or some wrap up questions and your views on things, I'll give it back to you guys.
Sure. Now we got the final section here for the next few minutes, and then we'll still have some more time for questions at the end. So, you know, first thing is, you know, the charts and the approach that we were just showing in those examples. To implement this yourself, you know, basically you need to enable trending on each air handler for, you know, this set of points, the temperature points to your damper and supply fan. 15-minute interval data is, you know, is fine. That's sort of a typical for BAS systems. You don't really need it more refined than that. And then, you know, you're going to want your controls contractor, you know, so assuming you know, have a BAS and a controls contractor, can help you set up the screens to actually, capture a nice, concise diagnostic like the one we were showing there for each one, and set up that outside air percentage calculation so that that can be part of your display. The outside air calculation, this presentation will get made available and it will be recorded, so you can refer to this later. But essentially, you're taking a ratio between the difference between outside air and mixed air versus outside air and return air, and that gives you your calculation. There's some things that you want to do, like given that sensors are not all calibrated perfectly, limit the results of that so it's within a 0 to 100. Cap the calculation there. When the fan is off, you're not supplying any air, so you want your outside air percentage to be 0. And the one thing about measuring things this way is that when your return air and your outside air temperature get to be very close to the same, then the calculation starts to become unreliable because the temperature sensors just aren't precise enough to measure those variations, and the mixing isn't precise enough. And certainly you can contact us for support. Now, a lot of schools, a lot of facilities, not just schools, but facilities around the state are going to have unit ventilators as opposed to air handlers. And you've got much more limited ventilation control here, but again, you've got to deal with what you've got. So there's not a way similar to that to have an analytic that's measuring your outside air percentage. Although it should be defined, within your mechanical documentation as to what that percentage is set up to be. One action that people should take if they've got unit ventilators is verify that when the fan runs, that the outside air damper actually does open. We certainly run into plenty of buildings, plenty of spaces where those outside air dampers are sealed shut. Or just not working properly in many cases. So you're going to want to look at that from a maintenance perspective. And then, if you run the fans on high so that more outside air is brought in, it'll increase the volume of outside air. It doesn't change percentage, but increases the volume. Acknowledge that this may lead to noise complaints, depending on, the equipment, how noisy the equipment is, the acoustics of the room, the sensitivity of the occupants, et cetera. So, that all has to be managed. There's never a one-size-fits-all answer here. And if you've got a mix of air handlers and unit ventilators in your building, then obviously the unit ventilators are supplying, some air that's not being measured from the air handlers. So that's, part of your sort of total HVAC equation. And lastly, looking at pneumatic buildings. So, all that was, kind of based on having a digital DESE system. But if you've got a pneumatic building, with, central air handlers, you can certainly do the same thing. You just have to go collect the data yourself, most likely. So, data loggers are relatively inexpensive. And, it just takes, 5 or 6 sensors per air handler. Some air handlers have 2 outside air dampers, minimum, and a economizer damper, so you get an extra sensor there. But it's usually fairly easy to set up. We did this in a building recently here, and it took part of a day to get those installed. And then the most the least expensive way, the cheapest way to harvest that data is just kind of weekly go and download the data from the data loggers. You can spend a little more money and get some things that will upload the data centrally, but the simplest way is to manually do that once a week. And then once you've done that, the data loggers will give you the same data that you had in those charts that we showed earlier. So you can do the same kind of analytics. You can pull that data, either into Excel and build the charts there, and do the outside air calculation in Excel. Or if you've got access to an analytic system, you can put it together that way. And here's the type of sensors that we're talking about. So supply air, something that's measuring whether the supply fan is on or off, measuring your return and outside air temperature sensors, some mixed air temperature probes, and again, having a couple of those in a mixing box so you're averaging the temperature in case you get some stratification there is a good thing. and then the units to collect that data, download that data. Down here in the bottom right, one for measuring the outside air damper position. So these are all relatively inexpensive, and get you the whole complement of data, and then everything that we talked about earlier, you can do the same thing.
And Kevin, those data loggers also capture CO2?
Some of them do. So I mean, it sort of depends on what you buy. Some of them will capture humidity, some of them will capture CO2. There's no CO2 component in the analytic that we showed to measure the percent of outside air.
Okay.
But
the only reason I ask is that seems to be the hot button ask from teachers, parents, families. They seem to understand the concept that CO2 correlates to air exchange. So that seems to be something that a lot of our members are looking for, is remote portable CO2 sensors to help satisfy what people are asking for. So that's why I was just curious if some have that function. That's great to know.
Yeah, some absolutely do have that function. But I would say, actually measuring the percentage of outside air that you're bringing in, is a equal or better measurement of actual air exchange. CO2 really is a measurement of how many people have been in there and how much CO2 you've expelled. So a lightly.
I couldn't agree with you more. It's just that I know that we're getting hammered with everyone wanting CO2, much like they all know they need MERV 13, they all know they need CO2 as well. So I guess if we can educate them and let them know we're actually capturing better data and educate them and explain to them what the data means, then that's a better solution. But it's all part of that, back to the communication component that you talked about. Let people know why you're tracking this data point and why you're not tracking CO2, because it doesn't provide as much information as tracking how much fresh air is coming in. So thank you.
Totally agree. Okay, and yes, part of this whole thing is being able to reliably, authoritatively respond to those questions that you absolutely are getting. So in summarize, and I know we're running low on time, but we know that all the facilities across the state are not the same. So it's really about doing the best of what you have. There's a couple nice charts that I won't go into in too much detail here, but again, you can sort of reference them. They came from the Harvard School of Public Health, looking at some of the work that they've done about reopening, which was one of DESE's sources. And basically this is saying priority is ventilate with outside. Priority one is to ventilate with outdoor air. So whether it's opening up dampers or opening up windows. Priority two is increasing the filter efficiency. So upgrading to MERV 13 if you can, or if that option exists. And then third option is supplement the filtration with portable air cleaners. And then this approach looks more at dealing with the ventilation system. So if you're relying on natural ventilation, this is where one of the recommendations about fans and outside in windows to promote airflow comes from. But if you've got mechanical systems, most mechanical systems are kind of the option on the left to supply air, where you're upping your ventilation, you're disabling demand controlled ventilation, and dealing with minimizing recirculation. There are building designs that the air sort of comes in one spot in the building, and then it's designed to be ventilated by air moving from area to area. And there you've got some other issues to manage in terms of how that air really does move from one section of the building to another, which is what the lower right is kind of addressing. So with that, let's go back to any questions we have in the last few minutes.
Yeah, Kevin, Bill Clayball had a question about whether, since you're going to 50% occupancy, does that change the data? Do we need to recalibrate anything? And I don't know, but it doesn't really matter. It's air changes per hour in the amount of circulation that you want, whether you've got one person or, a 50% loaded classroom, it's going to be the same set of parameters that you need to manage to. CO2 would say, oh, you can use less air, but
Correct.
that doesn't solve the problem that we have with airborne transmission.
If I could just add to that, Greg, the Mass Teachers Association is looking for 20 CFM per person of fresh air. So that would be the only thing that I would say for Bill is, you know, they're looking for a certain number to come in per occupant. So that might be the only calculation where a 50% occupancy would actually buy you a little bit of wiggle room, because you're not designing to full capacity. So it's not 24 kids in a classroom. Now you're looking at 12 kids and a teacher. So now you need 20 CFM for 13 people versus close to 30. So that's the only thing I think that might be a consideration. But like Greg had said, at the end of the day, you're just trying to get airflow through that building and meet everyone's guidelines.
Yep.
I think that covers most of the questions that we had relative to the presentation. There was one chat that came up relative to districts installing UVC systems. I think Mike D'Angelo is on the call from Franklin Schools. He's our vice president of the MFA, and they're in the middle of putting on the street a bid package to retrofit all their buildings with UVC lighting. But Kevin, have you come across buildings where people are, or any of the guys, you know, Bill or Greg, have you come across buildings where people are looking at UVC as part of their solution right now for COVID? And where do you guys fall on that area?
We've got one client who's actually looking at ionization systems for it, and you know, they were prepared to spend, you know, do a multi-million-dollar, you know, capital investment to put ionization systems in a it was at a community college level, but put ionization systems in, you know, across a whole bunch of colleges. That actually got off track for you know, political money shifting reasons that I won't go into. But you know, that was, you know, they had looked at that as while it was a big capital expense, you know, it was something that they weren't going to have to you know, then continually invest in, you know, other than obviously maintenance, but you know, it was a 20-year lifespan. And, you know, they looked at that compared to, you know, having to, if they upgraded all their filters to MERV 13, or they even looked at 14 and 15, the filter replacement expense, you know, skyrocketed, and the frequency of replacement. So, you know, it was an operational, you know, expense, you know, constantly. And they actually looked at ionization systems as, you know, as economical in the long run over a 20-year lifespan, you know, as, you know, cranking up the filter everywhere. You know, that's why they were, you know, heading in that direction.
Okay.
I am on the call.
Thank God, Michael. Yeah. You can talk about UVC. Let me just talk about briefly about bipolar ionization and UVC and the comparison of what people are talking in the industry. Kevin, we've had a lot of correspondence, a lot of discussions about this internally and both externally with some experts out there. Bipolar ionization right now doesn't have verified third-party testing that it's effective for the COVID virus. What they have is they have internal manufacturer certification. So I do believe it works, but that's where people are a little bit concerned that there's no CDC, there's no EPA, there's no DPH, you know, white papers stating that it works against this virus. You have to rely on the trust of the manufacturer's reports and the manufacturer's own internal testing. That being said, a lot of folks are looking at UVC lights. So Mike, I know we're short on time here. We may run a little bit longer, but if you could just kind of give a quick overview of what you guys are doing in Franklin with your UVC, I think that would help people at least know some of the possibilities that are out there, because you have various schools and various equipment that you guys are installing this in.
Correct. I've been working with an engineer, EMA, who has been working at some of the colleges in Boston, putting this stuff in and buildings downtown. It's been put in a lot of big places like the New York Stock Exchange, Walter Reed Hospital. But so the town of Franklin has committed roughly $2 million to put UVC lighting, because there's lots of science on UVC that tells you exactly how many watts per square foot based on the air moving through the air handler you need to sterilize the air. And it's all Homeland Security studies that were done many years ago when George W. Bush was president to kill anthrax and every other virus in the world. So we were actually out to bid as of Wednesday on a project to put UVC lighting racks in air handlers at Franklin High School. It's about $100,000 project, which is actually the easiest project we're doing, just because the size of the air handlers makes it very easy to do, to install. You have the large area where between the coil and the filters where you can put the correct wattage per square foot and be able to kill the virus. We're using other different methods, different types of currently manufactured UV lighting products that we're going to be going out with another bid to put in return air plenums and supply air plenums. And we're also working on we have a contractor building an kind of similar to a VAV box, but a box that will mount above a ceiling in a univent classroom, suck air up through it across a UV light pack axially down the tubes, and then push that air volume back down into the four corners of the classrooms. And it isn't cheap, but as a town and a school system, we're looking to and it has a K factor, and it has been proven to kill SARS, to kill tuberculosis. And so that's what we're doing for Corona, because Corona doesn't actually take, a SARS type virus doesn't take a lot of UV light to kill it. But UV light, we also at Franklin High School use it was installed before the building opened in 2014, because UV light kills bacteria. So we recycle all our water off the roof and store it in a 30,000 gallon tank underground. And then we pump it back up and into the toilets. But before it goes into the system, it actually goes through a big UV light, about 6 feet long, that's clear on the inside with 6 lights to kill all the bacteria in it before we pump it out into the toilets, just to make sure it's safe.
Cool. Well, thanks, Mike. And with any of these systems, you have to do your homework because there's for folks that dialed in to Guardian Energy's webinar we had about 3 weeks ago, Barbara was talking about energy projects where they're using troffer retrofits, that if you have a 2x4 troffer fluorescent light in your building, you can install a package unit that has HEPA filters in it, a UVC light, and LED lighting for the space, and potentially leverage utility rebates. Granted, you'll need 2 or 3 of them for a classroom to accommodate that space, but there's a lot of different technologies like that. I was just speaking with someone yesterday that has a similar VAV box type solution above the ceiling for univent classrooms, but they're using UV lights with HEPA filters as well. So there's a bunch of solutions out there. Bipolar ionization is one of them. It seems the teachers have latched on to UVC versus bipolar as far as one of their preferred methods of disinfecting. But at the end of the day, ASHRAE and most of the people from CDC and Department of Public Health and everything, it's dilution through fresh air intake. it's getting more fresh air in the space. And granted, that's going to crush us on our utility usage because now you're running your fans and motors more. Now you're running your heat with your windows open just for this pandemic portion. So there's, I think, and Matt spoke about it from DESE, that we're faced with a whole bunch of short-term solutions and mid-range to long-term solutions. So short-term, we need to figure out how to get our buildings as safe as we can to get people back in them. Long-term, how can we do that safely and not have to continually run our heat with our windows open? So it's a really tricky time for us now. And Bill and your team, Bill, Greg, Kevin, I did want to thank you all for today. I think it was really helpful, and I think it provided a lot of great insight for people and a lot of considerations. We are going to have, this was recorded, so what I'll do is I'll get this recording and I'll post it up on MFA's YouTube channel, and then I'll link it to our COVID resource page, so that way people can have their staff dial into it. Oh, thanks, Maria. Maria from the MSBA said thank you very much for the session. It was very informative. So thanks our friends and colleagues at the MSBA for doing what you do, and hopefully our newer buildings will be already set up to deal with these pandemics in the future. God help us all. So again, everyone, I thank you for dialing in. If you have any follow-up questions, you can certainly email me and I can get them off to Bill's team at Interval Data Systems. Interval Data Systems is one of our new sponsors on our website. So if you do need their contact information, it's up on our sponsor page, and they'd be happy to, discuss with you, reach out to you and talk to you if there's a solution they can help you with some of your buildings. So again, everyone, take care, enjoy the long weekend, stay safe out there, and we will keep in touch. Take care.
Thanks, guys. Mr. Miller, have a nice day.
Hey, Michael, thank you very much for doing this.